Hello and welcome. In this lecture video, I'm going to be talking about how to calculate the price of a bond. Okay, and we'll go through two examples, one with the present calculate the price of a discount bond, and then another to calculate the price of a premium bond, but really there's not too much difference in the two approaches. So when we talk about the market price of a bond, remember bonds are traded on exchanges. And so the price is really determined by supply and demand, just like anything. So what we actually have to do when we look at the market price of a bond is determined by supply and demand, but we can be more specific. And what we can say is that the market price of a bond is determined, or it's equal to, the present value of all the cash interest payments plus the present value of the par value. Remember, the par value is what we have to pay back at maturity for the bond. So we calculate the present value of the par value, and then we also calculate the present value of all the interest payments that we make to our bond holders. Now remember from Appendix B lecture videos that in order to calculate present value, we have to know the required rate of return, also known as the discount rate. So when we're calculating the price of a bond, the market rate of interest is the discount rate. So when we're talking about looking up in the table for present value, what rate do we look up? That is the discount rate, or the required rate of return. We look up the market rate of interest, not the contract rate. And I can even be more specific. It's discounted, the rate of return that we use, the discount rate for present value to calculate the price of a bond, is the market rate at the time of issuance. Okay? So when we talk about computing bond prices, we have two steps. First, we have to calculate the present value of the par value, and then we have to calculate the present value of our interest payments. So let's say, for example, we have a $100,000 bond. This is the par value, 8% contract rate, 10% market rate. You can tell this would be at a discount because contract is less than market. It's 2 years, semi-annual interest payments. So that means that we'll make a total of 4 payments, right? Total of 4 payments. So the first step is we have to calculate the present value of the par. And then the second is we have to calculate what our interest payments will be. What are our interest payments to our bondholders? Remember, it's always par value times contract rate. Par value times contract rate. Here's the par. The contract is 8%, but remember it's semi-annual. So that means we take the par value times 4%, and then that gives us 4,000. Then what we do is we use our tables that are in Appendix B. And remember, this is the present value of the par value. This is a single amount table. So when we are calculating the present value of the par value, we use the present value single amount table. Okay, table B.1. The number of periods that we look up is 4. The interest rate is based upon the market rate. That's the interest rate we look up in the table, which is our discount rate. Now you can see that's 10% market, but that's 10% per year, or 5% every 6 months. So the rate of return that we look up is 5%. If you look up in your table, present value single amount, table B.1, number of periods 4, interest rate 5%, here is your factor. And then we know from Appendix B, what we do is we multiply this future cash flow times the factor, and then that gives us the present value. Okay? So then that's the first step, which is calculating the present value of our par value. The next step is we have to calculate the present value of our interest payments, which in this case, remember, is $4,000. Okay, $4,000. And again, the way we got that right over here, that $4,000, is by taking par value times contract rate, which equals our 100,000 times our 0.04. And why 0.04? Because the contract rate is 8%, but it's semi-annual, so it's 4% every 6 months. Now, remember the term annuity, right? What is an annuity? It's equal cash flows equally spaced out. So the same dollar amount of cash flows every single time period. That's what an annuity is. Well, let's think about what these interest payments are. They're always $4,000 because the contract rate doesn't change and the par value doesn't change. So it's always going to be $4,000. And we pay $4,000 every 6 months. That is an annuity because it's equal cash flows equally spaced out. So this is an annuity situation right there. Okay? So what we do is we look in table B.3, which is the present value of an annuity table. Okay? The present value of an annuity table. And how many periods do we look up? 4 periods. Why 4 periods? 2-year bond, semi-annual, 4 total periods. What interest rate do we look up? Well, we based it on the market rate of interest, but remember that market rate of interest is annual. So our payments occur every 6 months, so we have to divide that by 2 to get 5%. Look up 4 periods, 5%, present value of an annuity table. This is our factor. We multiply that factor times our 4,000, and then that gives us our present value. So you can see up here, we multiplied with the present value single amount for our par, times our future value cash flow par, gives us the present value of 82,270. This is the present value of the par. That's what this is. This is the present value of the interest payments. We add these two together, and then this becomes the present value of the interest payments plus the par value. This is the price of the bond. Okay? And when you're solving these kinds of problems, it helps to set up a table similar to this, where we have our cash flow, then we have our interest payments, times our factor times the cash flow, gives us the present value. Factor times the cash flow gives us the present value. Okay? Now, if we're looking at a premium bond, it's really the same thing. It's the same steps. So we have our bond price, 12% contract rate, 10% market rate. We can tell that this is selling at a premium because contract is more than market. It's 2 years semi-annual. So just like the other problem, it's 4 periods. What interest rate do we use when we look up for our discount rate? What interest rate do we look up in the table? It's 5%. Why is it 5%? Because it's half of our market rate of interest. Our market rate of interest is our discount rate. Number of periods 4, semi-annual 5% right there. We get the same factor. And we multiply it times for our par value. This is the present value of our par, just like what we did with our discount bond. Now, let's look at the annuity situation, which is our semi-annual interest payments. That we said that's an annuity. The only difference is you can see the factor's the same as in the discount scenario because it's 4 periods, 5%. It's the same factor, present value and annuity. What differs is the amount of interest payments. In the other one, in the discount, it was $4,000, right? Because the contract rate was 8%. Now, our contract rate is 12%. Half of 12 is 6. 100,000 times 0.06 gives us the 6,000. So, you look on this problem. Here's the present value of our interest payments, which is the 6,000 over the next 2 years. This is the present value, 21,276. We take the present value of our par plus the present value of our interest payments, gives us the total present value. This is the price of the premium bond. Okay? So, what I want to do is I'm going to let you do this one on your own, but before we do that, I want to look at number 2 right over here. Okay? So let's do this one first. And so what we have with this situation is Alberto Company issues 8% 10-year bonds with a par value of $350,000 in semi-annual interest payments. On the issue date, the annual market rate is 10%, which implies a selling price of $87.5. So the first thing that I'm going to do is I'm going to multiply my par value times 0.875. Because remember, bonds trade at a percentage of their par. So this is the price at which this bond is selling. It's trading. 350,000 times 0.875, 306,250. That's the price of the bond. So now what I want to do is walk through an example of manually calculating out the price of the bond using our present value tables and making sure we get close to this number. Okay, so I'm going to set up a table. So I got CF, my cash flow, times my present value factor equals my present value. And I would encourage you to set up tables similar to this to solve these problems. So the first one is I have this $350,000, which is my par. And this is a single amount, just like what we went through. So what I'm going to do is I'm going to look in my present value of a single amount table, and I'm going to look at 5%, 20 periods. And that's the rate of that's the factor that I'll look up here. And why 5%? Because remember, I have to use my market rate as my discount rate. Why 20 periods? Because it's 10 years and it's semi-annual interest payments, so total of 20 periods. And when you look that up, present value single amount table, interest rate equals 5%, number of periods equals 20, you get 0.3769. You multiply those two, and then that gives you the present value, 131,915. What I do next is I have to calculate my interest payments. And to do that, I take my $350,000 times my contract rate. Remember, my contract rate is 8%, but it's semi-annual, so it's times my 0.04. And then that gives me $14,000. Those are my interest payments. $14,000. This is an annuity. Remember? So what I'm going to do is I'm going to look in my present value of an annuity table. Periods equals 20. 5% is my discount rate. And when I do that, I will find my factor of 12.4622. And again, that's from a present value of an annuity table. Periods equal 20. Interest rate equals 5%. You multiply those two. 174,471. We add it up. 306,386. Okay? That is the present value. This is the price of the bond. And you can see that is pretty close to what we calculated right over here. Now, why do we have a difference? We have a difference because really, this is truncated. It's really 0.875, right? 388. That is the true percentage. And so I just truncated to 0.875, stop there, multiply it times the par value, and that's why it's 306,250 and not the 306,386. It's a little bit off. It's just a rounding issue. And so when we ask, is this approximately correct? It sure is, okay? So I'm going to end this lecture video, and in the next lecture video, we'll do this problem together, and then this quick check problem, and then talk about retiring bonds. Okay? Thanks so much.